Welcome to Math Beyond Borders. Mathematics Simplified. Welcome geniuses. So in today's video, let's talk about equivalent fractions. So how to build equivalent fractions and how to look at them. And then we will also quickly talk about how to simplify them. Yeah, because simplifying fractions, I realize that causes a lot of problems sometimes. Some kids do not understand how to deal with that. So let's look at that in a video. So today's video will be slightly longer than usual, but I'll try to keep it as quick as possible. So follow along, all right? So equivalent fractions. Equivalent fractions are fractions that at the end have the same value, right? So for example, if I have a fraction 1/2, I can build equivalent fraction by taking the same action on the numerator that I take on the denominator. Okay, so what that means is that if, let's say, I was to multiply, let's say 2 on the top, I have to multiply the 2 at the bottom and it will give me an equivalent fraction. So let's do it together. 1 times 2 is 2. 2 times 4 is 2 times 2 is 4, right? So again, let me write it more clearly once again for you. So 1/2 is an equivalent fraction of 2/4. Okay, I can multiply this with a specific number and I can get the same. So let's just, for example, let's say we multiply this whole fraction with a 5. Okay, so let's say 2 times 5 will be 10 and 4 times 5 will be 20. Same fraction, equivalent fraction. Whatever action you take up, again, with whatever action, I only mean multiply and divide. It does not involve plus or minus because that is not how the progression in a fraction works. Okay, so the idea is whatever multiply or divide you do on top, that's the same multiply or divide you do at the bottom, or numerator or denominator, however you would like to call it. So for example, now if I was to multiply both of them by 5, let's say 10 times, or any number, let's say by 7. If I was to multiply both numerator and denominator by 7, 10 times 7 will be 70. 20 times 7 will be 140. Right? So similar fraction, right? So if someone asks me, is 1/2 equals 7/14? Yes, it does. 2 is double of 1, 14 is double of 7, right? Do you understand that? 2 2 times 1 will be 2. 7 and 2 times 7 will be 14. So 1/2 fraction, right? So let's try to build the same fraction with 4/5, and let's try to build that with a multiply by 5. Then that number multiplied by 2, and then that number, let's say, divided by 2. Okay, so that we see both the actions. Okay, so let's do that. So first it was a multiply. So 4 times 5 will be 20 and 5 times 5 will be 25. Same fraction, equivalent fraction, right? 4 times 5 as a fraction is equal to 20/25. Also, when I multiply this 20/25 by 2, so 20 times 2 will be 40 and 25 times 2 will be 50. Same fraction. All three of them are similar fractions. Same fractions rather. I'm sorry to call it similar. They are same fractions. They are equivalent fractions, right? Now, if I divide this fraction by 2, I will again get 40 divided by 2 is 20. 50 divided by 2 is 25. Yes? Okay? Or let's make it a bit slightly more complicated, all right? So let me bring in an eraser. Let me erase this part. And let's say we decide to divide it by, let's say, I don't know, by 5. Cool? So 40 divided by 5 is 8. And 50 divided by 5 is 10. All these are equivalent fractions. They all have equal value at the end. Okay, so that's how you build equivalent fractions. Now let's talk about simplifying the fractions, right? Simplifying those fractions when you have something. What does it mean, simplify a fraction? Simplifying a fraction means nothing but just bringing the fraction to its least or basic value. Okay, so for example, let me tell you, when trying to simplify a fraction, you usually start by using prime number, 2, 3, 5, 7, these kind of numbers. Okay, let's try to simplify it. So what does it mean? Simplifying will always mean, if it is a single fraction, simplifying it will mean dividing it and bringing it to basic terms. So I will show you, but follow along. So what number do you think is common? What basic number do you think is common in 12 and 18? 2, 3, 5 or 7? Well, the most basic assumption is both are even numbers, so 2 for sure, right? So if you divide 12 by 2, it will be 6. When you divide 18 by 2, it will be 9, which means my fraction, what remains is 6 over 9. Now we know both of them can further be divided, so it's not the most simplest form of the fraction. So what can that be? Let's try with the 3. We know 6 and 9 fall both with 3, right? So now 3 times 2 is 6. 3 times 3 is 9. So the final fraction is 2 over 3. Now there is nothing common number that can divide both of them. Again, the concept is same. We divide, but whatever number we use to divide it with in numerator, the same number we use in denominator, or whatever number we use at the top, we use also at the bottom, right? So that's the idea, that you simplifying is just this fact, right? So let's look at one more example for here. So you see 35 and 75. Now looking at these two numbers, one thing is clear, that they both can be divided by 5, right? So let's head on and let's do it. How many times 5 is 35? Take a guess. I'm not gonna tell you. So 7 times, right? Amazing. Now 75, slightly complicated, but I'm sure you guys can find it, right? This will be 15 times. So which means in a simplified form, my final fraction should be equal to 7 over 15. Now these two cannot be divided any further. There is no common number that can divide both of them. So we can just leave it at that. 7 over 15 is my final fraction. Easy, right? So let's do one more, just to be sure that we understand simplification, and then I will show you one shortcut of simplification again, and I'll let you go, right? So let's say you had a fraction 10 over 50, right? Which are the two numbers that you can divide it with? Again, don't think of a bigger number. You don't need to. Think of the smallest numbers that you can possibly think. Can they both be divided by 2? Yes, they can be. So let's start with that. If I divide this by 2, it will make it a 5. If I divide this 2, it will make it a 25. So it will be 5 over 25. Now you see both of them have a 5 at the end, so they can be divided by 5 for sure, right? So you can get, when you divide this by 5, you get a 1. When you divide this by 5, you get a 5. So that's my final fraction, 1 over 5. Simple, right? Now let's look at how you can reduce zeros straight away. Just remember, as a rule of thumb, that if you ever have a 0 in numerator and a 0 in denominator, you can straight away cancel it. So now, for example, you see 2 zeros here, you see 3 zeros here, you cancel these 2 zeros by these 2 zeros. What is left is 1 over 10. Simple. Zeros can be struck off in a multiplication or division equation straight away, right? Let me show you one more example. So for example, if I had 30 times 100 over 1000, what do you think I will do? How many zeros do you see here at the top? 3. How many at the bottom? Also 3. Let's try. So let's say this 0 will cancel this one, this 0 will cancel this one, and there is still 1 0 left which can cancel this one. 3 times 1 will be 3. So you can strike off zeros like this. So if you have zeros, you don't have to go to the pain of dividing it step by step like we did here. I just did here to show you, but you don't have to go through that. If it would have been 10 over 50, I could have cancelled 0 with 0 and 1 over 5 would be left straight. Easy, right?
Thank you for learning with us. Please share the video with those who you think may need it. Also, if you want to request a topic, put that in the comments section. So until the next video, keep learning, keep questioning. Bye.